Hello everybody! So you just finished learning about linear inequalities if we have just one equation at a time, and the solution here is some kind of shaded graph. So what if we have more than one equation to deal with? We have something that's called a system of inequalities. So I'm working off my section 6.5 blank notes that we have here in resources, so you can follow along with that if you have your own copy, or you can just write down what I'm working on. With a system, it's sort of like a system of equations where you have more than one equation, as you see down here, but instead of doing substitution or elimination to solve, again, our solution is a shaded graph. And because it's made up of every possible xy value, that satisfies the entire system of inequalities. So there's so many points that actually work here as solutions that we end up making a shaded area. All right. Well, basically to do this, friends, you're going to do what you did before in the video. You're just going to be doing it one at a time. But I have some good advice over here on the right-hand side that really works well. The first thing you make sure to do is when you graph and shade these, instead of graphing all of them together and then shading at the end, I like to do one line at a time. Graph it, shade it, move on. Graph the next one, shade it, move on. And graph the last one. If there's a third one, shade it, and then figure out your final solution. Okay? So, and also, it's really fun to do colors. So if you have any colored markers or pencils or crayons, these are really, really fun. Okay, here we go, guys. Let's try this first example here. As you see for number one, we have x minus y is less than 2. We have x is greater than negative 2. And we have y is less than 3. So like you saw in the video, it's really good if we can put these into slope-intercept form. But what I also kind of do, I don't know if he mentions this, but I change these inequalities into equal sign so I don't get so thrown off by what the actual inequality is. So we're really going to graph x minus y equals 2. And later we're going to graph x equals negative 2. And then we're going to graph y equals 3. You don't have to do this step that I'm doing, but it just makes the graphing of the line itself a little bit easier for me personally. For the first one, guys, let me take this one on top. Let's put him in the slope-intercept form. He is really y equals x minus 2 once I move everything around in order. Okay, that means he's got a slope of 1 here in the front, and he's got a y-intercept of negative 2. All right, well, let's graph that, and we'll see how it looks. Moving down to my graph down here, I'm going to graph y equals x minus 2. So like I said, it's got, let me give you a blue here, it's got a y-intercept of negative 2 and a slope of up 1 over 1, up 1 over 1. I really don't need much more than that because a graph of a line only needs really 2 points. All right, I'm going to connect those dots and make a line. I can see where it's going, but I do want to go back to my original inequality and just check and see, am I going to use a dashed or a solid line? And because this doesn't have an equals part in the inequality, this one is going to be dashed. If it was equal, then it would be a solid line. Okay, let me connect those dots with a dashed line as best as I can. Good. Another thing that I like to do from time to time, it helps me organize my thoughts a little bit, is I like to put numbers of each equation. So that was number 1. So over here, that's graph of number 1. I'll go ahead and number 2. And I'll number 3 over here. Just so I can keep track when it gets to be too many lines, you don't get confused. Now, before I move on, I said over here, it's really good if you can graph and shade before you move on to the next one. So let's figure out, if I look at my graph here, am I going to be shading the top left part or the bottom right part? If you remember from the video, the best thing to do is just to plug in a point and see if that point works. And the best point, if you remember, is 0, 0, because it's so easy to plug in. If I plug in 0, 0 and it works in my inequality, then I'm going to shade this half here. If I plug in 0, 0 and it doesn't work, I'm not going to shade the part that has 0, 0. I'll shade the bottom portion down here. All right, so let me make some room here. And let's plug in 0, 0 into my first equation and see what I get. Now, it's best that I plug it in here into the inequality, not into the equal sign, because that won't make sense. All right, come on over here. Let's bring him down here. This is x minus y is less than 2. Let's plug in 0 for x and 0 for y and see what happens. How about 0 minus 0? Is that less than 2? Meaning the left side is 0. Is 0 less than 2? And I'll be honest, I've been doing this for many years. I still have to stop for a minute and just think about it. Don't go fast. Is 0 really less than 2? Yes, it is. So because it is, then 0, 0 is the correct point in that solution. So we're going to shade the top left. So here's my shaded solution all up there. Okay, that's just equation 1. Now we're just going to repeat this for equation 2 and equation 3. And we're going to find the spot where all 3 shaded regions overlap. And that's going to be our final answer. All right, how about equation number 2? This is x is greater than negative 2, and I rewrote it as x equals negative 2. Remember, if it's an x equals line, it's going to be a vertical line at negative 2, right over here. So it's a vertical line going through negative 2. I checked the inequality. It's not equal to, so again, it's going to be a dashed line. So I'm going to draw a dashed line through negative 2, and that's equation number 2. All right, so I'm either going to shade the left-hand side of that or the right-hand side. Why don't we plug in a point and see? I'll do it over here on the right-hand side. So x is greater than negative 2. Let's plug in 0, 0. Well, there's only an x, so I'm just going to plug in x equals 0. Is 0 for x greater than negative 2? Pause for a minute, think about it. Is 0 really bigger than negative 2? It is. Okay, so I'm going to shade the part that has 0, 0. If you look at your graph, that's going to be the right-hand side of it, because that's where 0, 0 is, on the right-hand side. So I'm going to shade all of this part here. And so far, you can check right now, it looks like this little triangle here is where it's both the sort of yellow-orange color and the green. So that's going to be part of our final solution, I think. All right, we graphed, we shaded. Let's try number 3. Number 3 was y is less than or equal to 3. I rewrote it like this. Remember, y equals lines are horizontal line. So I'm going to draw a horizontal line at y equals 3 right here. Let me check. Dashed or solid? It's an equal sign, so I'm going to make this one solid. Oh, finally. Here we go. Y equals 3 is there. And I'm going to label that. That is equation number 3, so I can keep track of what I'm doing. All right, I'm either going to shade the top half or the bottom half. Shall we plug in 0, 0? Let's do it right over here. Y is less than or equal to 3. So plug in 0 for the y value, because there's no x here. Is 0 less than or equal to 3? Pause for a minute and think about it. Is 0 really less than or equal to 3? Yes, it is. So we're going to shade the part that has 0, 0, which is the bottom half. All right, let me get a good color. How about a blue here? So I'm going to shade everything below this line that has 0, 0. All right, and now we just need to look and see, of those 3, can you see where all 3 overlap? And it's not in the top left. Down here, there's no green over here. On the right-hand side of 2, there's a lot of green over there. So I want to see where the green and the blue and the sort of yellow-orange overlap. And it's right here. And that, folks, would be my final region. That's my final answer right there. It's hard to tell, but there are sort of, sorry if I break that up, but it is kind of dashed on that side. And it is kind of dashed on this bottom side as well. But it is solid up on top. And there's the answer for the first one, guys. So it's a lot like what you did on the video before. We just got more of them. So keep it very, very methodical. Like I said, do just one line at a time. Good job. Should we try another one? On the next page. Okay, this would be a good spot for you to pause the video, try it on your own, and come back and see if we have the same answer. All right, here comes number 2. Now I'm a little nervous because I see this x squared, but I remember the x squareds are parabolas, so maybe this is just a shifted parabola. All right, in my mind, I'm thinking x squared minus y is equal to 1. I'll graph that. And over here, minus x plus y is equal to 1. I'll graph that. All right, let me change these into something a little bit more readable. If I solve for y equals x squared minus 1. All right, that's a parabola opening up. That's just shifted down 1 using my transformations knowledge. This one looks like it's a line, so I'll put that in the slope-intercept form. How about y equals x plus 1? All right, let's graph one at a time, shade each one, and see where they come together. Okay, I'll try that on the next page. Just double check, did I write right? I did. Okay, here we go. So for the first equation, number 1, this is a parabola that's shifted down 1. That would be right here. And it's opening up, so it looks a little bit like this. But you know what? I got a little bit hasty on that. Did you notice I didn't check if it was solid or dashed? So I will go back. Whew, I was lucky, right? It is actually equal to. And in fact, they're both equal to, so we'll have 2 solid lines, not dashed. Phew. All right. Now, I need to figure out, am I going to shade inside the mouth of the parabola or outside the parabola? Well, 0, 0 is inside the mouth, so why don't we check with 0, 0 and see if 0, 0 works. Come on over here. Now, I'm going to go back to my original equation. That was x squared minus y is less than or equal to 1. It's easier to go back to the original because that's where the original inequality sign is looking like less than or equal to 1. I didn't flip it or anything, so it's easier to plug into the OG. All right, let's plug in 0, 0, folks. Is 0 squared minus 0, is that less than or equal to 1? So 0 squared is just 0, minus 0, there's another 0. All right. Is 0, think about it, really less than or equal to 1? And it is. So I'm going to shade the part that has 0, 0, which is inside the mouth. So he looks a little bit like this. And number 1 is done. Okay, let's move on to number 2. Equation number 2, same steps. Y equals x plus 1, that's a slope of 1, and a y-intercept of 1. So he starts about here. And I saw before that he was a dashed line, so up 1 over 1. He was a solid line, excuse me. So I'm going to draw a solid line. I was going to label these two. Here's equation 1, here's equation 2. All right, so there's my line. It is solid. I'm going to check 0, 0, which is actually below and to the right of it. And if it works, I'll shade the part that's below and to the right. So I'll do that off to the side here, over here. And let's plug in 0, 0. But let me check my original inequality statement was negative x plus y is less than or equal to 1. And let's plug in 0, 0. So is negative 0 plus 0 less than or equal to 1? Negative 0 is just 0. Plus another 0, I'm thinking 0. All right, is 0 less than or equal to 1? Same thing before. It is. So I'm going to shade the part that has 0, 0, which is down to the right of it. So it's going to look a little bit like this. That's the portion that has 0, 0. All right, can you see where they both overlap? It makes kind of a neat little sort of half of a leaf or sort of a teardrop pattern, but it's right here. And there it is. That's the final answer to that one. There's your final shaded region. How did that go? Now, there's one extra part in the actual problem, if you saw, is to actually ask not just sketch the inequality and shade it, but find where they both intersect. Now, my graph is not particularly exact, but I can tell that they definitely intersect here, but I don't know where that is exactly, and here. So how can we figure out where they intersect? Well, I guess they intersect where they're equal to each other, right? Because that's where they're the same. Right there and right there. Well, if they're the same, then like I said, that's where y of one is equal to the y of the other. So what if we set them equal to each other? That's where they intersect. Let me try that. Let's set x squared minus 1 equal to x plus 1. Now, this looks like it's going to be a quadratic, so I think I'm going to have to move everything over to the left side and set it equal to 0. That looks pretty good. That one factors really nicely. How about x minus 2, x plus 1? That means x equals positive 2 and negative 1. All right, that looks pretty good. Let me look at the graph. Does that really make sense? Does it look like that this over here is that x equals 2? Yeah, I think so. And it does look like this one over here is that x equals negative 1. But it says points of intersection, so maybe I should find the y values too. All right. When x equals 2, what's the y value? Well, for which one? Actually, both. Why don't we just plug it into either one? You can plug it either into the top one up here or the second one. It doesn't matter because they should have the same y value. And test it just to be sure. If I plug in 2 to either one, I should get 3. If I plug negative 1 into either one, should get 0. So the answer to that, where do they intersect, should be at 2, 3. Let's look at the graph and see if that's right. 2, 3. Yeah, I would argue that's pretty good. That looks like 2, 3. And then also at -1, 0. Should we check? Wow, that -1 is really close to 0 there too. -1, 0. So 2 answers here, friends. The shaded region and then the 2 points where they intersect. Great job on that. Why did you try number 3 and 4 on your own? And I'll make a new video walking you through the answers for you to check. Good job, everybody.